Well, g'day flatties and globe defenders, it's Critical Think from Down Under. I'm going to talk a little bit about these three videos that were put out within a week by Phuket Word not so long ago. The first one was about surveyors supposedly seeing imaginary curve, and then there was a correction video, and then another video about horizons and a lot of things. I'll only touch briefly on that one. I'll be addressing a particular theme in these videos, and there's a lot more material to go through, but I won't be going through it today. So we'll just start with the introduction to the surveyor's video.
We're going to have a look at how surveyors can interpret the calculations and measurements that they make into an assumed curve of the surface of the Earth.
So there is this idea that surveyors can take measurements and then make an interpretation that there's curvature, rather than the measurements themselves dictating that the physical reality must be curvature. So this is a ridiculous concept that we can interpret measurements to be what we would like them to be, rather than what they physically represent. And I don't know where this idea comes from, but of course, if you want to believe the Earth is flat, you have to come up with these wacky ideas that have no representation in reality. Now, this is an example. I have in reality here, just say I have a piece of wood. I know it looks a bit like a block of cheese, indeed it does, but it's actually a block of wood. Cheese or wood doesn't matter. So I'm going to model this block of wood, but first I'm going to measure it. I measure all the sides of this block of wood, and I find that they, let's say they're 3 inches, 4 inches and 5 inches. So then I make a model of this block of wood, and I draw on a piece of paper the model. I've taken these measurements, I've modeled it with these lines here, 3, 4 and 5. Now, this represents the reality of the block of wood. No, it is not the block of wood, but it represents the reality. So from this model, I can determine that this angle A has to be 90 degrees. Now, there is no other physical reality that can fit 90 degrees. I cannot interpret that and say that angle is interpreted as 70 degrees. It cannot be. It must be 90. And if I take these three sides, 3, 4 and 5, and that is modelled as a triangle, I cannot interpret that as a square. It's a triangle. And even though it's not the piece of wood itself, it's an accurate representation of it, and the mathematics of that triangle are reflected in the reality of the piece of wood. If I were to go to that piece of wood and measure the angle on those, the ones between the sides 3 and 4 there, then I would measure 90 degrees. I wouldn't measure anything else. So the idea that we can somehow make measurements and then interpret it any way we like is a completely ridiculous idea. But that's the basis of Phuket Word's proposal here.
So it would appear that the angles they measure go below this line of sight, indicating that there is some kind of curvature.
So here's where it gets a little bit interesting. This diagram here is about levelling. It's not about measuring curvature. He's talking about using a theodolite. The angle you would measure with a theodolite would depend, of course, on what you're trying to do, but if you were to measure that stake and look at where the same height is on a level surface, on a curved earth it would be lower, so the angle would be lower. But Phuket Word is getting this a little bit confused with this diagram, which is actually a level measurement, and it's not a geodetic measurement. So this picture here, you will not measure the Earth's curvature, as you can see with the narration on the picture. This is for measuring level and at the same time accounting for the Earth's curvature. and we'll explain that in a minute.
And so what's actually happening is we have perspective being converted into an assumed curve of the Earth.
So what he's trying to say here is that the angle that you look across the Earth can change because of perspective, and that he's implicating that surveyors don't take into account perspective when they're taking their measurements. This is, of course, ludicrous. A surveyor is a professionally trained person. They know what they're doing, and if they didn't know what they're doing, there would be all kinds of funny things happening in the world, and nothing would be the way that it seems. So for the rest of this video, Phuket Word will try to establish how a surveyor may be tricked by perspective. But first, before we go on to that, I'll explain a little bit more about this diagram, because Nick doesn't understand this diagram and what it's all about. It's about finding level, and you wouldn't use a theodolite necessarily with this. You could, but you normally use a dumpy level or an auto level to do this measurement. So you take a distance halfway between A and B, and then you sight along between A and B. And if A and B are level, then the difference will be 0. So let's have a look at that. Now there will be an error which is represented by small e for this instrument. Now this could be as a result of a calibration error, a small calibration error, or as a result of the curvature of the Earth causing this to be a little bit lower even though it is level. So let's represent that error as E, and E can also include the effects of refraction. So E is the error in your measurement. So when you sight along here to A, then you're going to get an actual measurement of HA and E. HA is the actual height, E is the error. You sight along to B, you get HB plus E. And when you subtract the two, HA plus E minus HB plus E, you end up with just HA minus HB, and the error is cancelled out. So that's how you make your level measurements more accurate, and this can work over the curvature of the Earth. And level is always perpendicular to the local down. However, like I said, this has nothing to do with what Phuket Word is talking about. He's shown a picture of a level measurement, but what he really means is doing a geodetic measurement, which measures the curvature of the Earth, either by reciprocal zenith angles or sighting angles to something of the same height. So this is the measurement that he's talking about. This is the correct diagram.
This is from a surveyor who's done his own measurements, and in his mind, those measurements are being done over a spherical Earth.
Yes, a surveyor has done these measurements, not like you, who is just offering an explanation. And the measurements dictate the shapes that are compatible with the measurements. Remember the block of wood? Well, if you make these measurements and they can't possibly fit on a flat Earth, that's the reason why it's curved. That's the reason why the surveyor knows that it's curved, because the measurements, just the same way I measure a block of wood, I know that it's a triangle with a 90-degree angle in there. So a surveyor has done the measurements. There's no surmising, there's no assumptions. The only physical reality that fits the measurements is indeed the curved surface. Now remember this, Nick, when you said that explanations are not measurable proof and you need measurements?
So these explanations are not scientific. They're not backed by any measurable proof. And that is the problem.
That's the problem indeed. So here you're offering an explanation, and the guy who has the measurable proof, you're not taking notice.
Yeah, again, it's all just interpretation. The plumb lines are being interpreted as doing this because something further away is going to be lower than the visual line of sight.
So he has got a little bit confused here. He often confuses visual line of sight, horizontal line, level, eye level. These things often get confused in Phuket Word's mind. So if we have a level line which is represented by that horizontal plane, and we do a line of sight to an object of the same height, then there will be this drop from level if the surface is curved. Now, if the surface is flat, of course, there will be no drop. But in this video, Phuket Word is trying to say that this drop here is due to perspective. So that gets interpreted as they're being curved. But this is incorrect, as we'll come to see. So this is the incorrect explanation. That's used as the total basis of this perspective being interpreted as curvature. Just remember that this is the whole point of this whole video, is that things in the distance grow smaller and therefore the angle will go down. So this is the whole basis of the video.
Size, the photographer stays where he is, but then the person or the object or the stick that was right in front of the photographer here is taken further away into the distance, and of course will appear now below the photographer's line of sight.
Well, this is obviously wrong, but Nick, in his haste to say that surveyors don't know what they're talking about, he's made a big boo-boo, but we'll get to that.
Then, as I pointed out, then the line of sight is going to be lower than this horizontal line. So with a theodolite here, just like a camera, this would go down. The angle would be lower than the original horizontal angle.
So there's no doubt about it there that Nick is saying there that as something recedes into the distance, it will get lower due to perspective. And this is the part that Nick knows is wrong, and he's going to retract that in the next video. But the thing that he forgets about is, and all his followers conveniently forget about, is that this is the basis of the whole video. This is his point about surveyors not taking into account perspective, about perspective being the imaginary curve. And it's wrong. Well, let's get into that.
I'd like to make a correction or clarification about this particular point in the video that I put out yesterday.
So he said correction or clarification. Well, it is a correction. And we'll listen to the correction here. It's good on you, Nick, for correcting something that was wrong. But if you go watch the video, you'll see that he has to spend the entire rest of the video trying to explain away his idea that surveyors can't possibly be measuring the curve of the earth. Apparently it's all just a concept.
This person's height doesn't change, and as long as they go away from the observer on a flat surface, then of course they will remain at eye level for the observer. Yeah, but of course, in the eyes of the observer, they will appear to be smaller. So yes, I should illustrate that like this, to represent that particular point, that when we are referring to eye level, someone of the same height goes off into the distance and they will remain at eye level.
Yes, you should illustrate like that. But you don't understand that you've just destroyed a bunch of flat earth arguments. You've just destroyed the perspective is the imaginary curve. You've just destroyed the flat earth with that. But of course you'll continue to defend it. And I'm not going to go into the bollocks that followed. You can go and listen to that if you like. But here's the thing. In his very next video, not more than a week later, he's up to the old tricks, the same old tricks about perspective being the imaginary curve. Even though he acknowledged what he said was wrong, he's bringing it back again in the very next video.
The simple fact that the further away something is, the smaller it will appear, has been converted into this imaginary curve. So even though the most distant peak, Peak Gaspard, is physically larger than Grande Ferrande, it will still appear smaller because it's further away.
Peak Gaspard is taller than Grande Ferrande, and the observation height is also taller than Grande Ferrande. So just Peak Gaspard getting smaller due to perspective is not going to make it lower. It can't happen. That's a physical impossibility. And Phuket Word acknowledged that in his previous diagram. This one, he's acknowledged that that's not right. But then sprouts this rubbish in the next video. And flat earthers just don't notice. They just lap it up. They just don't notice what just happened there. So if you think that perspective can substitute for curvature, flat earthers, I have a problem for you. Here I have 3 stakes in the ground. The first one is 283 centimetres high. You can make it feet if you want to, it doesn't matter. 275 centimetres is the second one. So the eye is looking over the second stake because the eye level is at the top of the first stake. And then the third stick is 388 centimetres or feet, whatever you like. As long as you use the same units in all 3, it doesn't matter. So what the proposal is there from Nick is that if you move stake 3 far enough away, it'll get small enough so it'll drop below the eye level of stake 1 and stake 2. So if you move it far enough away, the top of the stake 3 should go below the top of stake 2 if this is a level surface. So, can any flat earther tell me then how far away do I have to move stake 3 so that the top is seen below the top of stake 2? If you can solve that, then you'll convince me that perspective is the imaginary curve. So, don't just say it. Solve this problem and I'll believe you.